A nibble is half a bite, and so welcome to today's Tech Nibble, and where we're going to talk about mitigation against Rowhammer. Now, what's Rowhammer? It's a memory problem that modern computers have that's been around for 10, 12 years. They've known about it. And get this, the way it works is that if you constantly hammer the same row in a DRAM chip, in a memory chip, so that's right, called Rowhammer, if you constantly access that row 100,000, 150,000 times, one after the other, then you can get some other bits to flip in different places in the DRAM chip. So it's to do with the way DRAM chips are designed and physical interference, but only if you really hammer it. It's been proved that you can turn it into an actual exploit where you can actually, gain access to a system. So Microsoft have just published a blog post about how they're mitigating against Rowhammer in their latest Azure Cobalt 200 SoC. Now, the Azure Cobalt 200 is an ARM-based server chip. It's got 132 ARM Neoverse v3 cores in it. And they built special circuitry into the system on a chip in the memory controller to mitigate against Rowhammer. Well, the way you mitigate it, of course, is you just see that someone's hammering that same location, which means you have to kind of keep a count. Now, of course, the problem is memory addresses are 64 bits long, so you can't say every time I see an address I'm going to keep a count on it, because you would just need so much memory just to count the memory. But there are some different algorithms where you can kind of see the frequency of certain elements in a stream of data coming. In this case, the of data will be the different addresses, and it's a way of being able to get the frequency, an estimate of the frequency of a certain element in a stream of data, in this case the addresses. And so using that, they're able to check to see whether any particular row, because Rowhammer, is being attacked, and then mitigate against it if it is. In fact, it's got 3 levels, this technology built into the memory controller. On the first level, basically it's just kind of checking to see if anything's under attack, and that has 0 effect on the bandwidth of the memory. They've built it into the SoC, and there's no impact on the memory. After a while, if it kind of gets suspicious about a particular row of memory being attacked, then it kicks in a slightly higher level of mitigation and checking of what's going on, and that can change the bandwidth by about 8%, lower it by about 8%. And then if it's really certain, it goes into the kind of the full defensive mode, and that does drop the bandwidth by about 23%. But you only get to that when an actual attack is happening. When the system isn't under attack, there's 0 kind of impact on that. Okay, I'll see you in the next one.